So today I want to talk about HTML5, and I want to talk about Internet Explorer 9 and how Microsoft is approaching HTML5. The agenda is easy. I will start with the standards, and I will walk you through the standards, web standards, and what web standards means for Microsoft. And then I will also talk about the performance. And so all the work that we are doing behind the performance to allow you to build scenarios using the latest web standards. But before I get into that, and here I really want silence. This is a sad moment. You might... You might remember this. How many of you use i6? Come on, don't lie. i6.
I still have i6 because I need to make sure that 60% of the world.
How many of you have still i6? Okay, you're more than welcome to leave the room now. I'm joking, you can stay. i6 was a great browser. It's been released in 2001. At that time, Wikipedia was not on the web. So it was a completely different web. And for that web, i6 was great. I remember I was an i6 user, and I never complained. Today, the web is changing. You know that we have different requirements. We are building different sites. We are more online. And i6 is not a browser designed for today. And so you probably saw the funeral of i6. We fully support it. We sent flowers with a nice message. i6 is our legacy browser. We ship i7, IE8, which is a great browser, is available today. And now I'm here to talk about IE9 and where we want to go forward. And then when we talk about HTML5, many people think that HTML5 is not part of Internet Explorer 8. But as Brad said, this is not completely true. In fact, we have already started implementing some of the HTML5 features that Brad showed you earlier in IE8, sorry. So you already find like network connectivity, which is something that, okay, let me show you something, for example. So I have here Visual Studio. How many of you are familiar with Visual Studio? Considering that this is a Java crowd, I can see a lot of hands. Visual Studio, as you know, is the best developer tools ever. Oh, by the way, I need to clarify something. I'm a developer. My heart is a developer heart. I do write code. I'm not a marketing guy. So if I make this assertion, I really feel it as a developer. Right? I'm not trying to sell you Visual Studio here. I mean, it's free. You can go in there. No. So one of the new features that we included in IE8 are like the network events. For example, you can see here that I have a body, and attached to the body I have two events, on online and on offline. Those events are raised basically when your network connectivity goes down or returns back. For example, let me open this page on the browser. Let me go simulate a work offline, and then your web page knows that the site is offline. Why is this useful? Because if you have a web application, and for example, the user is profiling himself, right? He's writing the username, password, where he's born, date of birth, etc., etc. And then when he clicks submit, the network goes down. You can basically get that event, you cache everything locally, and then when the network connectivity returns back, here you are with the data. How can you store the data? Well, Brad made a great presentation, an overview of HTML5, and he talked about the local storage. And the local storage is exactly that space that, as you can see, is available in IE8 as well as the other browsers, where you can have like a hash table, and you have like the set item. It works like a hash table, so you have a key and a value. And so local storage.setItems set the value. Local storage.getItem will get the value. And then notice here that I'm using JSON.stringify, and this is just like a way for serializing and deserializing the content. You can have your own binary formatter or any other form of serialization. Obviously, we support cross-domain, so we have this new object called xDomainRequest that allows you to do the cross-domain requests that you were asking about. We have native JSON support. The JSON, how many of you are familiar with JSON? Okay. Oh, wow, everyone. So how many of you are using external JavaScript libraries to handle with the JSON? Okay, for those of you that are using the external libraries, as you know, initially JSON was available through a library, for example, from JSON.org, or through jQuery, or through other frameworks. And then we saw that many developers, as I can see in this room, were using it. And so we thought, why don't we just embed it inside the browser? And so we made a JSON object available like natively. This is a native object. You can see that I'm not using any external library here. You don't need to create anything. It's already there in the browser, and you can use it straight away. Same way you were using the external libraries. Why? Because we are following another standard. This is not part of the HTML5. Actually, it's part of the ECMA5 script, which is like the specification for JavaScript. And it's very fast. In fact, in this other demo, and by the way, all that demo that I'm showing you today, I'll publish those on my blog so you can see the source code and read and learn from that. In this demo, I'm iterating using the JSON library first, and then using like the native implementation of IE8. And I'm doing just like I have a loop, a silly loop, and I have a silly like stringify and parse every time, right? And when I run this in the browser, you can see the performance difference between the JavaScript implementation and the native implementation. And the reason for this is that obviously the native stuff is written in C++, and we can optimize it. We can do all the optimization that we need. And we will see this JSON as well, native JSON in IE9 as well shortly. And then we have a bunch of other stuff like Asian navigation or the selectors. So you saw what the selectors are. In IE8, we have partial support for the selector. We don't support all of them, but we allow you to query selector all, most of the selectors. And then in IE9, we keep building on top of this. All right, and this gives you just a quick overview of what's available already today using IE8. And let's talk about IE9. I'm here to talk about IE9. IE9 is, as you know, our next browser. As you probably heard, we announced the first platform preview at Mix about March timeframe, and we released the first platform preview. Last week, we released the second platform preview. And basically, the goal of the platform preview is just to start showcasing what's going on internally. One of the feedback that we heard from the community was, we don't know what Microsoft is doing. We don't know what Microsoft is thinking. Where the hell are they? And so this is why we are shipping platform preview every 8 weeks, to show you the progress, to show you what we are currently implementing, so that you can start planning ahead of time your solution and your application. And the platform preview looks like this. Right? It's a very silly UI. I mean, there is no navigation bar. There is no button, stop, next, nothing. If you want to go to a website, there is this very nice feature, page, open, and then you have the modal box. Now, this is fantastic. Like, when you get used to it, it's very nice. Now, the question is, when do you get used to it? But there are tricks to go over this, and I will show you shortly. And then you can see that the homepage goes to this online page where basically we are collecting some of the new demo that showcase new functionalities of IE9, either for web standards or for performance or in general for graphics. And by the way, this presentation is all based on demos. I want to show you demos of IE9. So let's start having fun. Microsoft is committed to web standards. And I'm very serious when I say this. It's not a joke. Okay, so this was not a joke. In fact, Microsoft, you know that how the standards works, right? You have a rough idea. There are organizations, for example, the W3C, which includes several working groups. There is like the HTML working group, there is the SVG working group, the CSS. And we've been committed, we've been working with these working groups since probably the beginning, including the HTML5 working group. This is not something that born like this year or last year. It's been there for 8, 9 years. And we've been in the HTML5 working group since the beginning. And we're collaborating also on those task force, which is kind of like a group in the W3C that take care of testing that the specification is implemented correctly across browsers and identify possible challenges, possible different behaviors. For example, when we look at the HTML working group, Paul Catton is a Microsoft employee. Previously, it was Chris Wilson. You might have heard of him. He's one of the co-chair of the working group. So it's like in the leadership of the working group. And then our team in Microsoft of engineering team is made of program manager, developers, and testers. And almost all of the program managers are actively participating in this space. There is like a public mailing list that you can subscribe to. You can go and read what our thinking is, what our questions to the rest of the members are, what Google thinks, what Mozilla thinks. This is a very open space where we debate and we talk and we sometimes fight, sometimes we agree on what the specification should look like. And then there is this HTML5 document. I'll be honest, my manager asked me to read through the HTML5 specification. And I was like, yeah, sure, that's my job. And then I said, I'm going to do it this afternoon. And then I start reading it. And then I started reading it. And then at the end of the day, I was like, oh, gosh, I'm still at the first paragraph. And not because I'm slow, because this is very, very large document. If you print it, it's like 800 pages. I'm not counting them anymore. But it's a very large specification. And anybody can read the specification, and anybody can say, actually, I think that this line is wrong. I think that this concept, this tag should behave differently. I think that we are missing, for example, the security model for the web workers. I think that the SQL blah, blah should work in a different way. And so everybody can submit a bug. When the bug is approved by the leaders of that working group, the bug become an issue. And until there are open issues, the specification will remain in a working draft state. So if we look at like a snapshot of the HTML5 specification at like mid-March, there are quite a few bugs and quite a few open issues, which are big issues. The extensibility model, that's a big issue. And we are working with all the other implementers, the members of the community, to understand how we can agree on what we can agree, how we can move this forward. So HTML5, the message here is HTML5 is great. We love HTML5. We love it so much that you will find a lot of HTML5 in IE9. But at the same time, it's not done yet. And there are still conversations happening. You asked previously, like, how is the geolocation working? Who asked the permission to the user about permitting that data? Those are like issues that the specification doesn't cover yet. And there are many similarities, many similar cases like that one. With IE9 Platform Preview 2, we are committing to support HTML5. We're committed to support XHTML, CSS3, SVG, DOM level 2 and 3. This is not like a commitment to all the specification, because that's very, very tricky and difficult because those specifications change daily. But we're committed to build on top of those specifications and to start keep implementing on top of that.
How about JavaScript?
Yes, so JavaScript will be ECMAFI script 5. Oh. Okay, exactly. So I just said JavaScript is also the group where that's Mozilla. The group where JavaScript is defined is called ECMAFI script 5. Definitely is there. We already been working on that with IE8. We will have that's definitely an important space for us. But the focus with the first platform previews is on this specification. And as I will say later, we are not done yet. So this is not like the full, complete set of specification that we will support in IE9. This is what we're already supporting with the Platform Preview 2. And then in the coming weeks, you will hear more. So let's talk about the markup languages. You are familiar with HTML, right? HTML5 is kind of like an extension to the HTML specification. It basically defines better how the user agent should parse the content. You know that any browser basically takes your HTML, and then there is a parser that translates that into the DOM, document object model. And in the past, each browser did a different job handling and parsing the HTML. And this creates like a complexity to you when you want to create animation or you want to interact with your page. Now, the HTML5 specification defines very well how the browser should behave. And so we have written our parser to be compliant with the HTML5 spec. We also allow you to integrate SVG. SVG in previous browsers, if you wanted to use SVG with previous browser or current browsers, you probably need to save it as an external file or to embed it as an object, as an image, or create your page using XHTML. The HTML5 specification allows you to embed SVG inside an HTML page. So you have just like an HTML document, and then you have an SVG fragment. IE9 has been the first to implement this. And then I'm happy to see the other browsers that are following up on this. I was talking with a guy from Opera last week at the Web 2.0, and he told me like they are definitely committed to implement the same, because basically this allows you developers to ramp up with SVG more easily without the need to create an XHTML page. We support XHTML, obviously, and SVG in all the shapes and forms that you see here. Microsoft is committed to web standards, and Microsoft is supporting web standards. This is not a marketing message, again. I don't want to give you just a message. That would be too easy. Behind the standard, there is a lot of work. There is very, very lot of work. And the reason is that those standards, those specifications, they keep changing. If you look at the specification today or last week, there are a lot of differences. Part get removed, part get added, part get changed. And so it's not easy to create something, to implement something that will remain the same over time. So our job as implementers, as browser vendors, is to make sure that we give you a professional implementation of the HTML5, something you can rely on, something that if you start building your application today, in 1 year from now, they will not break just because the standard changed. And this is a problem. This is a very big challenge. It's called interoperability. We had this challenge in the past, always. And we will always have this challenge by definition. With IE9, we are spending a lot of time making sure that whatever we implement doesn't just work on IE9. We're not doing the IE9 implementation of HTML5. We're working a lot creating with the W3C to make sure that our implementation is a solid and robust and professional grade browser. Let me show you an example of this in action. So this is an internal site with a few demos, and I want to show you the border radius. How many of you liked the previous demo about the border radius? I mean, it's awesome. It's just super cool. It's like every developer, at least once in their life, wanted to use the border radius. And so all the browsers said, yeah, we implemented the border radius. And it's great, because it's true. Each browser, all the other browsers implemented the border radius before us. But then when we start working on the border radius with IE9, we found out interesting behaviors. For example, I have here just like a rectangle with a few properties, and then you see the border radius here. And I'm doing some animation, for example, to the border. I'm changing the cycle and animating the border. Right? And you can see the border radius as Brad showed before. It's pretty cool, no? It's just like, I mean, this line is doing the difference, the border radius line. So let's try the same demo on Firefox. Right? Same code. But actually, the only difference that you will see here is that I'm using the browser extension, because Firefox doesn't support yet the border radius like natively, so they are using this vendor extension.
The value specs.
Sorry?
The value specs for border radius, is that finalized?
It's in a storage state, yes. Yes. So same code with Firefox. I animate the border, cycle the border, animate the border radius, and ooh, the result is different, right? Let me put them side by side. You notice that we are getting different results. And so when I saw this the first time, I said, OK, let's try with another browser. Let's try with Chrome. Oh, by the way, I'm running like all the latest. So this is Chrome 5. I have Opera 10.5.3, I believe. So animate with Chrome, cycle, animate again. Oops. We put side by side. You notice anything? Gosh, it's different again from Firefox, and it's different from IE. But there is Opera, so Opera will tell us the truth, right? So I run Opera, animate, cycle, animate, and ooh, no, once again, different from Chrome, different from Firefox, and obviously different from IE. So why is this? Didn't all the browsers implemented the border radius? Yes. Is this a solid implementation that developers can start using today? No. And so there are many challenges like this. There are many interoperability issues in the current implementation. And the work behind Internet Explorer, and in general, the work that we are doing in Microsoft, is to identify those issues. And it's not just us, by the way. I mean, we are doing a lot of work. We have a lot of testers in our team that are checking all the possible parts of the specification and make sure that the browsers behave consistently. Lastly, we want to offer to you something that is reliable, that works seamlessly across browsers. If each browser implements the same spec in a different way, well, probably somebody failed. I'm not sure if it's the browser, it's the specification guys, but somebody did a mistake in some point, and we don't want to get there. We want a very good implementation of HTML5. And by the way, which one do you think is correct here? But, OK, I'm pushing the boundaries. I mean, the other browsers are doing a great job, and this is one of the issues. There are many issues with JavaScript, with HTML, etc. Sometimes we are in the wrong position where we are making some mistake. But this is a very tough problem. We talk about interoperability, and how can we get over this? Basically, we are building test cases. You're familiar with the idea of test case, right? Test. For CSS 2.1, we've written 7,200 test cases. I repeat, 7,200 test cases. You know, if you are writing tests, you know how long it takes to write so many tests. And we keep doing the same with IE9. And we are submitting those test cases to the W3C so that are available to all the other browsers, all the other implementers, and so that we can find areas where eventually we need to discuss. Maybe the specification is not clear enough, and we need to talk together, understand what's the difference in the different implementation and how we can sort it out. And you can see today that just looking at some of those test cases, the result is quite different from browser to browser. Those test cases, by the way, are available either on the Microsoft site today. We submitted all of them to the W3C, so they will be part of the official test suite. But you can go there and have a look and express your opinions. And then let's come to the other nice tag feature of HTML5, the video. The video, as Brad said, allows you to embed a video inside a web page without using plugins. It's pretty cool, pretty neat. What is the problem, one of the issues with the video? It's the codec. We didn't talk about codec previously, but basically, the W3C, the HTML5 specification, doesn't specify what codec browser should use, which leaves a big question for the browser. What codec should I use? And so each browser came up with a different codec or different ideas, different thinking, different reasons. I personally, as developers, I really wish that all the browsers will agree on the same codec, because lastly, that's what allows me to write some website more quickly, more easily. We in Microsoft look at the codecs that are available today, and we realize that H.264 is the de facto standard. I mean, it's broadly used by many websites. YouTube say that they were going to build on, they already have like prototypes of their videos running using H.264. Facebook is the same. Even the hardware support is very important, because when we start talking about mobile devices, so devices will need to run HTML5 at some point, and they already have like hardware decoders for the H.264 codec. For example, I have here like a camera. This is called like flip camera. It's the most cheap camera that I could find on the market. I'm recording a video, so you can smile now. Or you can say, yeah, I love IE9. Brad, say, I love IE9.
I love what IE9 is doing with HTML5.
That's enough. So I'm recording a video, right? And then from here to the web, it's easy as I'm plugging this USB camera to my laptop. It recognizes this as an external drive, as you can see here. I just have a small application that allows me to copy the video on my local hard drive. And then I prepared a very complex page. You will see the source code in a second, where I can go. And here it is, right? And I have your video running in IE9. And the source code, that's it. So like few seconds, and then now let's listen to Brad saying, I love IE9. We don't need to listen to the same. I will cut there. again, you saw the simplicity to go from a camera to the web page with a video. No plugins, no conversion, no encoders. It's just like copy and paste, one line of code, and you get the video in the page. This is HTML5. It's really like something that helps developers. Same way as for the video tag, we are supporting the audio tag. And in particular, we are supporting the MP3 codec. One other difference that you will find in the video implementation that's available on IE9 platform preview compared to other browsers today is that we use the GPU. The video is accelerated by the hardware. So I will talk again about the hardware support, but basically you get all the benefits of running this using the hardware layer, meaning go full screen with an HD, very high quality video, something that on Flash today will not work exactly well. You can do like things like overlay of videos with other content. You can animate videos. You can have multiple videos inside the same web page. There are really a lot of new scenarios that are enabled by the video tag. The other big specification that we implemented in IE9 is SVG. In SVG, you saw it. It's very easy. It allows you to draw graphic on the web. Now, let's run some demo. And I will start with an object that you might recognize. So this guy is SVG guy. It's not an image. In fact, if I take my developer tools and I inspect, for example, an eye, you can see that I just went to the circle that defined the eye, and I have like other paths that define the various parts of this component. And I can, for example, say, let's change this to red. And automatically my Clippy now has a red eye. And you can see as the developer tools are integrated with the SVG. We already have full integration between SVG and developer tools. For the developer tools, SVG and HTML is exactly the same thing. It's not like a standalone component in the page. They are very intrinsic in the browser. And so you can start using the APIs and JavaScript the same way you were doing previously for your HTML. Okay, let's go to something more complex. Let's have a look, for example, to this demo. This one has been built by one of the engineers during a weekend to test the SVG implementation. And it's a very popular game, you know it is, and oops. Okay, so to avoid these scenarios, I have the protection mode, and now I can bounce into any object and nothing happens to me. But then the manager of this PM was kind of upset because he was spending a lot of time playing instead of working. And so the engineer came up with this nice feature where now it's kind of like, it's in office mode, right? What is the difference between this and the normal mode? And then when you start shooting, you don't have any more. And you can see the performance of this demo, right? And then this was not enough. And so it created like this mode called Nebula mode, where the background changed very, very quickly. And you have this like animated background. And if I run this the frame per second, you can see as the frame per second are very high, about like 48, 40 frames per second. If I run the same demo using Firefox now, what do you think will happen? It runs, good. Firefox supports SVG, obviously. But then when I go to my Nebula mode, the performance is quite different. And the frame per second will show you that it's below 10 frames per second. This might seem an issue with the code, but the code is exactly the same for the two applications. So where is the difference? And you can probably hear my fan that is doing like an Uber. The hardware is the difference. Because again, SVG is accelerated by the GPU, is accelerated by the hardware. And so with IE9, we are the first to take the hardware and use the hardware to accelerate anything that happens on the web, as we will see shortly. All right. With SVG is a nice specification that is made of many modules. And we want to be very transparent up front about what we are going to support and what we are not going to support in IE9. This, again, is our way to demonstrate our open commitment to the community. And so you can see in the first column what is currently partially supported in the platform preview. By the time we ship, we will support all of those modules. We will leave out some of the other modules. And the reason, for example, is the SVG font is a way to define what fonts you want to use using SVG. But then Brad showed you that there is another specification called CSS fonts that does exactly the same. And so right now there are conversations with the SVG working group, and we are talking about the fact, like, why don't we just take the SVG fonts and the CSS fonts specification and we bring them together, we merge them together instead of creating duplication. And so this is where we are involved and we are working right now. Same for declarative animation, it's also called Smile. There are people that absolutely love it. It's kind of nice, but at the same time, there are other people that believe that it's just an override. It's another language the developer should use. You can see how we can achieve animations using JavaScript. And so this is where we are, what we are starting with in this first release. And then, again, HTML5 is a keyword, but the reality is that it includes an umbrella of several standards. CSS3 is another of those standards. And as from the previous presentation, in IE9, we already support the CSS3 color module. Again, the nice thing about CSS3 is not like HTML5 huge specification. It's made of modules. So I can say, yes, we support the CSS3 modules. If you ask me, do you support HTML5? That's a very tough question to answer. We support the selectors. So we already have a full support for all the selectors that are specified by the CSS3 specification, as well as namespaces. And the namespace, basically, for those of you that are not familiar, allows you to style your custom object or your custom elements that are defined like with a custom namespace inside an XML page. I can show you here a couple of very quick demo. For example, let me show you the alpha and opacity, and you can just achieve like operation of fade in and fade out using CSS3. Or you can have like the selectors. So one of the questions was, how can I select my checkbox or input box? You can see here, for example, that I'm selecting all the input box that are not enabled. Or I can select only the first child. Or I can create my own selector, like selection, which basically allows me to start selecting the content, and then this will get like my style. Or like on a table, I can like remove tables. Or the interesting thing about this demo that you see like the demo on the left, and on the right you see the representation of this demo with the DOM. So you can see how the DOM translates this into like a proper tree. The other very nice, one of the other modules in the CSS3 specification is called Media Query. And the Media Query allows you to start thinking about the idea that your website could be rendered on a large screen as well as a mobile device. And so you can basically change the CSS property depending on some property of the device, of the screen. And so you can see here, I have like 4 boxes with a title, a description, and an image. And as I start reducing the dimension, you see that there is a switch in the CSS. And then if I keep going, I basically go to my mobile version. No JavaScript. This is only CSS. And so with CSS, you can say, if the screen is smaller than 200 pixels, then use this layout. This is like a very nice feature, especially when you start building application for mobile devices as well. CSS3 selectors, we already succeed. This test that comes from the CSS3.info site that goes through like all of the selectors. And then the last big part is DOM. It's DOM level 2 and DOM level 3. And with IE8, we've done a lot of work to make our implementation Trident, our engine, compliant with the DOM. With IE9, we are adding even more. So for example, probably one of the major things that you probably know is that on IE8 or IE7 and IE6, you have the attach event, if you want to attach to an event. In IE9, we support the add event listener. So, and not only that, but the add event listener basically got like upgrades when it went from the DOM level 2 to level 3. And our implementation is already looking forward, and so we support like new events. For example, one of the latest events that we implemented is the DOM content loaded. Watch this page. Poof. You see, I have 3 images. Until now, if you wanted to do something on the page, you attach it to the event load. But the event load is raised only when all the content in the page get downloaded on the client. And so if I have images, basically all the images will be downloaded, and then you get the load event. The DOM content loaded, the one on the left instead, is raised as soon as the browser goes through your DOM. So it's much faster. If I reply this, you can see that you are done. You can start working with the JavaScript much more quickly than before. If you're using jQuery, and it seems like a lot of you are using jQuery behind the scenes basically try to use the DOM content load to start executing the JavaScript. So by default, you don't need to touch anything. jQuery will run very fast on IE9. And so I'll give you an overview of the standards. Now let's switch gear and let's talk about performance. Because you can have the best platform in the world, but if you don't have the performance that you need in order to build your scenarios, then you're kind of limited. And so with IE9, we really look at the performance stack and we optimize everything for performance. And I will show you something today. But before reaching the demos, I want to do with you the exercise of going through like a page load in slow motion. So classic scenario, I'm on my favorite search provider, right? And I want to navigate to the Wall Street Journal website. So I click on the Wall Street Journal link. And what the browser, and this is valid for any browser, and what the browser starts doing is like rendering the background color properly, like some CSS property. And then it starts parsing the header and it starts showing elements on top. Then it builds the header, and then probably builds the rest of the page. But it's not completed yet. In fact, then he adds like the layout, and then he brings like the media elements and videos, and then he brings like additional layout or tables or Ajax content that happens on the client, and lastly, like always, the advertisement and the banners. As you can see, there are several components in the page load. Now, an exercise for you. It's not to start dancing, but you see here different sites, and each site has different properties. All of those are new sites, so they're very similar. But as you can see, they have like a different size, they have different number of JavaScript lines, different number of DOM elements. Now, my question to you is, which one is the fastest? Can you give me the number? 3. Anybody else? All right, you all agree on 3? And the fastest, 2, the fastest is 3, it's correct. Why? Because it's very small. It's very fast to load. Let's do the opposite. Which one is the worst one? Which one is the slowest one? The first one. The second one. The last one. And the answer is the fourth one. The fourth one? Why the fourth one? I mean, the size is not too bad. And in general, it's not too bad. But the way this website is using the JavaScript to talk with the DOM or to talk with the CSS is not optimized. And so even if it looks like it could be fast, then when the browsers actually start working with the code and start working with the parsing, etc., it's not very fast to run that because the website is not optimized. So the question is, how do I know? Like, how do your developers know if your website is optimized or not? Well, there are many best practices, but lastly, it's up to us, browser vendors, to make sure that any website runs very, very quickly. And so if we look at 2 of those sites and we look at it side by side, you can see as the browser spent a different amount of time and CPU working on different areas. The columns that you see here shows you like some of the major components of any browser. Like you have a JavaScript engine, you have a DOM engine, you have a parsing engine, layout, rendering, the marshalling, etc. And you can see, for example, on the left, JavaScript is just like 10–15% of the overall time. On the right instead, you can see as JavaScript is 25% of the time. Again, on the left, there is a lot of time spent on rendering. On the right, there is a lot of time spent on layout. So when we look at the performance of IE9, we look at this analysis, this data analysis, and we say, we need to optimize everything. We need to optimize the JavaScript, yes, sure. But we also need to optimize all the other layers, all the other subsystems. And so when we look at the Wall Street Journal website, in IE8 and in IE9, this is how they look like. So let me explain you this. This axis is the time, which means that IE8 took about 7 seconds to render the site. IE9 can do it in less than 5. This axis is the CPU, meaning that IE8 was working with the CPU at 100% in a few clock cycles. IE9, just 3. So you can already see like the performance difference between IE8 and IE9. But then you can also see how less work is done in IE9. Why? 2 reasons. First one, we're using the hardware. GPU. We're using the GPU to do all the rendering. And I will tell you later something more about the GPU. And the JavaScript also is accelerated by the hardware. So how many of you have a multi-core machine, like dual core, etc.? Everyone, right? So we thought, why don't we just use those core? And now the JavaScript is compiled in the background core. So you have 2 cores, right? The browser starts reading the JavaScript. And then if we read scenarios where we need to compile, basically we send the code to the second core, it compiles it, and then it goes back to the first, to the main core. And this obviously gives us like a performance boost with the JavaScript. By the way, this is tricky. I don't want to get too much into the detail of the JavaScript architecture. But if you're doing a lot of like float calculation in JavaScript, we might send them to the GPU, because sometimes the GPU is even faster to do those than the CPU. And this obviously improves the battery, improves the load time of site and everything. So time to show some demo. I'm back on IE9. And what I want to show you now is, let's start from this one. I have some text, and look at the animation when I start animating this font. You see, it's kind of smooth. If I run the same in Firefox, I'm picking a random one. I could pick any other browser. No, I'm serious. I could pick Opera or Chrome. They would do the same. But you can see that this time is not exactly there. Why? Because this animation is rendered using the GPU in IE9, and is just used by the CPU in other browsers. OK, let's try with a different one. This one is very nice. Let me. This one is online. It's called Flickr Explorer. And basically, it pulls images from Flickr in real time. So if my connection is on, you can see those images arriving. This is real time, right? There is no caching, etc. And as a matter of fact, I could search for custom keywords. And then you have these images, and you can browse through images. You can look at the details. You can see kind of the performance here. What do you think? This is fairly smooth, right? Now you understood the game that I'm doing, Firefox. So same demo, same code. Where are the images? OK, eventually they will arrive. But you can see that the performance is kind of different, right? And I don't want to wait here for the rest of the presentation. So let's close this. Then I also talk about JavaScript. And the reality is that when we look at the JavaScript code, obviously we want to make our JavaScript engine faster. But we also do something more than that. We look at your website. We look at the top 7,000 websites. And we look at the APIs that are used by you developers. And we look at the APIs that are mostly used by websites today. And we optimize the performance for those APIs that are actually used. So for example, the index of or the get element by ID, those are like widely used. And so the new JavaScript engine is called Chakra, is optimized for those functions. And when we look this in a, let me see if I have a demo of this. Let's run the net.json test. So this is native JSON running on IE9. Can I open Chrome as a comparison? Native JSON running on Chrome. Boop, boop. There is some difference. And again, this is one of the possible scenarios. But you can see the performance, like we are working on real-world APIs. We're really working on optimizing the APIs that are mostly used. Like in this one, I'm doing a test with a bunch of very common JavaScript APIs. And you can see as like things like the index of or others that we showed previously. And it's kind of like 2007 in IE9. Same one in, same one in Chrome. Slightly more, right? There is like an API here that is particularly slow. And this is the kind of work that we are doing in IE9. It's performance of everything. Rendering, performance of JavaScript, and JavaScript not like benchmark like SunSpider, but also real-world APIs, things that developers use today on the web. But that doesn't mean that obviously I cannot show you the result of SunSpider. This is what the SunSpider, this is like one of the benchmark, JavaScript benchmark from the WebKit team looks like. So you can see different browsers. You can see the IE9 build that we show at PDC in November of last year. You can see the platform preview 1 that we shipped in March. You can see the platform preview 2 that we shipped last week. And as you can see, we are getting down. And I want to do an exercise with you. Take the first one, Google Chrome 5. It's great stuff, very fast JavaScript engine with SunSpider. And compare it to like all the other browsers, right? I believe that we have all a very fast JavaScript engine at this point, because the gap between us and the fastest is exactly this. This is scientific. Close your eyes. Now close your eyes, everyone. Now open your eyes. Now do it again, very quickly. That's the gap, right? So if you run this test, it takes about 70 seconds to run. And after 70 seconds, the gap is exactly what you saw in your eyes. So I think that we reach a point where the JavaScript engine are very fast. And I was talking with Croc for last week. Definitely we can be faster, and definitely we will be faster. But we didn't finish yet. I mean, we didn't ship IE9 yet. We will be faster, don't worry. Don't worry. But it's time to also move to the other part. You remember when I showed you the different components in the browser. So it's time to move to the acceleration also of the rendering, of the graphic, of the layout. I mentioned the GPU, and you might think that the GPU is this huge thing on game machine with like blue lights and water that cools down the system. Well, actually, no. Actually, the GPU today is very broadly available. I'll bet that most of your laptops will already support a GPU. Netbooks have a GPU inside. Mobile phones have a GPU inside. You heard about Tegra or similar GPUs. And so why don't we just use it? And this is why IE9 is using the hardware, is using the GPU to accelerate anything that happens on the web. And when I say anything, I include really anything. HTML, SVG, CSS, all the animations, the video, the audio, everything will be accelerated by the GPU. For free. I mean, you don't need to do anything specific. It just comes automatically for you. And so your websites that are available today, they will automatically be much faster because we will run them on the GPU with IE9. Now I want to show you another demo that I really like. And the reason is that it's been built by a very smart guy in this room. This is a joke. And this is available externally. So let me open here the platform preview 2. And let me go to what I call flying images. This is built using HTML, using CSS, and JavaScript. And it's about 20 lines of code. It's really nothing very impressive. You can see as I move the mouse up and down, it follows my icons. Move left, right, it just follow my icons. And you can see the performance, right? I can increase the number of items. Ooh, and you can still see the performance of those items rotating. Again, GPU accelerated. And notice at the frame per second, 60, 61, 55 frames per second with 144 items. It's pretty cool, no? OK. Let's close IE. Try another random browser. Well, sorry, it needs to be fair. Let me go to 144. OK. Well, it's not exactly there, right? At least not on my machine. Why? Because Chrome as well as Firefox or Opera, they don't use hardware acceleration yet. I wish they will, but today this is not supported at least not in Chrome 5. I'm sure I saw some daily, nightly after mix that were mentioning this. But I think you get an impression of where the web is going, right? HTML5 is a great standard that allows you to build completely new scenarios that previously were not possible. And so I want to wrap up here, showing you the difference with the previous chart, right? I showed you this earlier for the Wall Street Journal. Let's have a look to the same performance review of the flying images. Again, time, you can see the time. The first color is JavaScript. It's the time spent on the JavaScript. The second color is the time spent on rendering. The third color is the time spent on layout. And that is IE8. Now, how does exactly the same code, same demo runs on IE9? What do you think? So what previously took like half a second, now it's like 10 milliseconds. The CPU previously was 100%, now it's less than 40%. And this is enabled by GPU and by CPU. I mean, that demo is not even stressing the GPU and the CPU. It's just like an Hello World demo. And I'm really looking forward to see what you guys will build in the coming years. So what I show you today is just like an overview of the current status of IE9. This is the platform preview 2. We will have other platform preview every 8 weeks to show you the progress that we're doing internally. And then the beta version is when we're going to introduce all the UI and the user experience. So there is much more to come. Now, we have a few minutes left. I'd really like to thank you for your time and take any question that you may have. Thank you. Yes. So the question is, I heard that IE9 will support H.264 and only that. Why you're not supporting other codecs, even if they are available on the machine? Right? So it's correct. The current plan is to support only H.264. And I don't want to spend too much time talking on this because the video conversation could take like another session, and it would be very interesting to say which codec is better, which one is faster, which one is more secure, et cetera, et cetera. I'll tell you that Dina Kanovic is our general manager, Internet Explorer, has written 2 blog posts, fairly long, with 500 comments below, and he replied to the comments, and he answered your questions. So if you go to the IE blog, is the first one, you will see exactly the answer given by the general manager. And then we can follow up on offline. There isn't anything that I want to hide, it's just that it's written there. Yes? So the question is, where does the JavaScript get compiled? So the architecture of this JavaScript engine is complex. I mentioned that we are using the multi-core to do background compilation. This happens only if you need background compilation. And we understand this using some heuristics. It's a very complex algorithm. There is a video on Channel 9. It's an interview to 2 of the senior program manager in the JavaScript team, channel9.msdn.com. And they show you like the architecture of our JavaScript engine. And they will tell you when one thing goes to one specific area versus another. As a developer, is there a roadmap to expire 6, 7, and 8? Yes. Did I answer the question? But let me show you something that, no, I agree. There is still IE6 out there. Actually, depending on where you are in the world, is different. Like I was in Sweden 3 weeks ago, and the people there complained because they had a lot of IE6 users. So I asked them, how many IE6 users do you have? And they said 5%. That's pretty good compared to China, where I was last week, where I asked, like, how many IE6 users do you have? 75%. So the reality is different from market to market. In terms of support, we support Windows XP. How many people here are using XP? So basically, the IE6 support is tied to Windows XP, meaning that we have to support IE6 because it's part of Windows XP. Obviously, you can upgrade to IE8. We've been shipping IE8 for XP since the beginning, but those two goes together. So basically, the answer is when we stop supporting XP, we will also stop supporting IE6. We already stopped the support for Windows XP Service Pack 2. I think that we will support the Service Pack 3 for other years, but I don't know the details exactly. My call to action in this case would be, again, developer talking to developers, smart people. I don't want to sell you a product. XP is an old operating system. It's great. Probably that is one of our mistakes. It's too great. But at the same time, we have a lot of new stuff coming with 7. IE6 is an old browser. If you're still using IE6, please upgrade to IE8. If your users are using IE6, please help us educate the users and show them that IE6 is an old browser. I'm writing myself a library that basically allows you to identify IE6 users and offer them IE8. Something else that I want to show you here is like a tool. It's called Expression Web Super Preview that allows you to test a website using multiple rendering engines. And so, you can see here that I'm loading a website, and side by side, you can see how this website would look like. For example, on IE8 on the left, oh, sorry, let me zoom out, and Firefox on the right, or IE6 on the right. And then you can identify areas where each browser behaves in a different way. This is one of the tool that we build in Microsoft to help you investigate IE6 website and move them to IE8 and to standards. So the question is, what are you doing with web workers and storage, etc.? Are you using the GPU? So there are obviously scenarios where the GPU is needed when you do the rendering, and others where you just do it in the CPU. IE9 currently doesn't support the one that you mentioned. We support obviously local storage, but we don't support the web workers yet. And the reason is that, as I show you, supporting a standard is more than just implementing something. It's also making sure that we all agree and the standards is there and the community is there. And there are currently issues. For example, let's take the database. Currently, each browser is experimenting with a different database model. We believe that the IndexedDB is probably the right model, and we are working with Mozilla to validate this approach. There are other very valid solutions. Currently, we didn't take any solution yet. But as Microsoft, our commitment is to build anything, really anything from here going on top of the GPU. So whenever we will add feature X, if that feature requires the rendering, we will just use the GPU because we have the core system, so we can do it. Perfect. Now, thank you very much again. I see you have other questions. I'll be around. Thanks.